Well, thanks everybody for this invitation, Alan, for the invitation. And it's been really just a fantastic morning, which I'll try not to prolong any longer than I have to. I feel very sorry for the poor souls who had to go 20 seconds per slide, and I sort of feel guilty like that I'm not, that hasn't been imposed on me. But I'll actually try to get close to that. I just have to say that this has been really an extraordinary morning. I think, first of all, the kinds of presentations that came this morning that have been the very best of science, harnessing the resources at Stanford, and into a laser-focused approach on developmental disabilities is a real head start here. I mean, this is a really unusual collection of presentations to find at any institution, and I hope everybody knows the value of what you actually have here to begin with, the substrate here, which is really quite remarkable. And I think you'll see from my presentation that, first of all, that there's a great deal of convergence, I think, in our field, or emerging convergence about where the true frontiers of discovery for developmental disabilities actually lie. And I can only say that my hope would be, especially given the talks that I heard this morning, that this day today would only be an introduction for my own collaboration with this center, because it really is a very impressive group of people that you're bringing together here. So this is the model for our IDDRC. So I don't really care about us stealing each other's ideas, so I'm going to lay it all out here very briefly. But I hope that we're going to be able to collaborate. The way that we've designed our IDDRC is along the lines of everything that's been talked about today, that we, at every level, from model systems, including cells and animals, to brain signatures, a neuroimaging core, to clinical and translational behavioral kind of phenotyping, that we believe that these have to be core abilities within any serious developmental center that's studying developmental disabilities and trying to position themselves on the frontier of where new discovery is going to be made. We're lucky at Washington U because we have one of the greatest sort of genomic and gene sequencing capabilities in the world. And so we're not going to reinvent that in our IDDRC, but we're going to capitalize on it. And we have a clinical and translational research program at Washington U that's separately funded. So we have some things that we are positioning our IDDRC and really linking very tightly with some of the institutional resources that are strong and that we don't need to reinvent. The reason this is such a busy diagram is that we believe that a developmental disability research center needs to be somewhat of a hedge. It has to be positioned between studying mechanisms of causation, and then when mechanisms of causation are identified, then they have to be flipped into translation. So very quickly, what this depicts is genetic influences. I'm sorry, most of you can't see this, but genetic and environmental influences that impact on the developing brain. And using our core facilities to advance what is known about how genetic influences, environmental influences, and their interaction actually impinge on a developing brain at various levels. We need to be very strong in continuing this campaign to understand that at a much more specific level, as is going on here. But then when we see a real clue, and whether that clue is retinoic acid, or it's, it dawns on us that there's a protective effect of gender across numerous kinds of developmental genetic pathways, or any of the things that have been talked about today, then somebody is thinking very carefully about how do we flip that into the translation. And this is kind of the road to translation. It begins at preconception with helping parents to understand, or prospective parents, what their risk is for an inherited disability or a liability for their children, and then going through preconception through prenatal and perinatal time, postnatal development, targeted biological therapies for children, minimizing the heaping on of additional environmental hazards when you've already got a disability, and then ultimately making sure that the adaptive functioning of an individual is at its very highest level. That's sort of the translational road. And we have, studies that have come off of our IDDRC These are, you know, major investigations that have a hand at each one of these levels in the translational pathway. And I think making sure that, that a center is conscious of all those opportunities. Where are all the opportunities? One thing that hasn't been talked about today is that one of the real, very important causes of developmental disability across the board, which really is on the environmental side, is the problem of prematurity and preterm birth. And so, for example, if we could end preterm birth, the public burden of developmental disabilities would reduce substantially, would plummet. And so thinking about making sure that we think about in our whole package of what do we want to be able to do to reduce the public health burden of developmental disabilities, there are these kind of sleeper issues that don't necessarily quite relate to the brain in the way that we usually think about them. But if you don't give the brain oxygen right here, you have a lot of problems. And so a lot of our IDDRC was initially built because we have very strong newborn medicine and a strong focus on all of that, on making sure that we protect children as best we can who have been born premature and understand how better to help them. But we kind of, at our IDDRC in the first phase, there wasn't as much emphasis on all the things that are talked about today. And frankly, I think we have to have a strong presence on both fronts, and that's what we plan to do.